Ever wondered why we can breathe on Earth, but we'd need a spacesuit on Mars? Or why Venus is a scorching hot pressure cooker? It all comes down to their atmospheres, and no two planets in our solar system have the same one. So, why the huge variety? Let's break it down. First, let's talk about how a planet gets an atmosphere in the first place. When a solar system is young, it's a messy cloud of gas and dust. As planets form, their gravity starts pulling in this surrounding gas. This is what we call the primary atmosphere, mostly made of light gases like hydrogen and helium, the most common elements in the universe. The gas giants, Jupiter, Saturn, Uranus, and Neptune, their immense gravity keeps these light gases from escaping, which is why they are so huge and gassy today. But for the smaller rocky planets closer to the Sun, like Earth, Venus, and Mars, the story is different. The intense heat and solar wind from the young Sun stripped away their original light atmospheres. So, they had to start over. This brings us to the second stage, the secondary atmosphere. This new atmosphere comes from inside the planet itself. Think of massive volcanic eruptions spewing out gases like water vapor, carbon dioxide, and nitrogen from the planet's interior. This process, called outgassing, is the main source of the secondary atmosphere. Comets and asteroids crashing into the young planets also delivered water and other gases, contributing to the mix. Now, here's where things get really interesting. 3 key factors decide what happens to this secondary atmosphere: the planet's size, its distance from the Sun, and a little something called a magnetic field. Let's start with size, or more specifically, mass and gravity. A planet needs enough gravity to hold on to its atmospheric gases. Mars, for example, is much smaller than Earth. Its weaker gravity couldn't hang on to a thick atmosphere. Over billions of years, much of its air, especially the lighter gases, just drifted off into space. This is a major reason why Mars has such a thin atmosphere today, less than 1% as dense as Earth's. On the other hand, Earth has just the right amount of gravity to keep a substantial atmosphere wrapped around it like a cozy blanket. Next up is the distance from the Sun. This determines the planet's temperature, which has a massive impact. Take Venus. It's a little closer to the Sun than Earth, but its atmosphere is a runaway greenhouse effect nightmare. It's packed with carbon dioxide, which traps heat incredibly well. Early in its history, any water on Venus would have boiled away, creating even more water vapor in the air and other greenhouse gas. This created a vicious cycle, making the planet hotter and hotter, until it became the 465 degrees Celsius inferno it is today. Earth, being a bit farther away, was cool enough for its water vapor to condense and form oceans. These oceans were crucial because they dissolved a lot of the carbon dioxide from the atmosphere, preventing a runaway greenhouse effect like the one on Venus. Finally, let's not forget the unsung hero, the magnetic field. Earth has a strong magnetic field generated by its molten iron core. This field acts like a shield, deflecting the solar wind, a constant stream of charged particles from the Sun that would otherwise strip away our atmosphere. Mars once had a magnetic field, but it died out billions of years ago. Without this shield, the solar wind has been blasting away its atmosphere ever since, contributing to its current thin and cold state. Venus also lacks a significant global magnetic field, which has made its upper atmosphere vulnerable. So, when you look up at the sky, remember that our breathable, life-sustaining atmosphere is the result of a cosmic lottery. It's a delicate balance of the right size, the right distance from the Sun, and a protective magnetic shield. From the gassy giants to the rocky worlds, each planet's atmosphere tells a unique story of its birth and evolution. It's a powerful reminder of just how special our own blue marble really is. Thanks for watching. If you enjoyed this journey through the solar system, don't forget to like, subscribe, and hit that notification bell for more space explorations. See you next time.